Namaskar, welcome to Prakash on Basics. I am Prakash Zoe. We've been talking on lasers. Last time we looked into the medical applications of lasers. We talked of the more common medical applications that are around. Today let's look into the other areas where lasers are put to use. Industry, day-to-day life, communications, military purposes and so forth. Let's look into industrial applications of lasers first. They become a very important tool nowadays. Right from the time they started using lasers for a variety of purposes, they realized that they could make things very simple in industries. So it's a major tool nowadays, and it works in both forms, either in the form of a pulse that is given out, or the beam could be continuous itself, both forms. Why do we use it? The reason is simple. These laser cutters or laser tools are very cheap. The cutting that is obtained has a very high edge quality. These beams can be focused to a very small cross section, as low as 0.2 about around 25 microns and much lower. They can also be focused in different manners. So this is how lasers are put to use in industry, but controlling them is not really very simple. And so nowadays there is a tendency to use what is known as CNC machines, computer numerical machines, or rather computer numerical control machines, CNC machines. These are the ones that are used very often nowadays. They can be used to control, switch on, switch off, move around, and they are not going to make any sort of a mistake. There can be no errors that are going to be produced. So you would find, and they will run continuously for hours together. You don't have to work in shifts. Once the process starts off till it actually is stopped, it would continue. So it's a very good method of continuing with industries where time is the essence, and the tool itself is very powerful. And what about the energy content? It can work from very low wattages, but they are not used in industry. Industry usually starts off with around 2 kilowatts or more, and then moves on to not only 20 kilowatts but also right up to gigawatts. And what it does is, because of, and it produces either very small pulses of very high energy for a very short time. Time could be 10 raised to minus 4 seconds or 10 raised to minus 6 seconds, that is 1/10 of a millisecond or about a microsecond. So an extremely sharp amount of energy burst is given to a given spot, or it could be continuous depending upon the requirement. And in that time, the amount of energy given to a place which cannot dissipate the energy, so the metal at that point practically vaporizes, and then naturally it will either be sucked out or blown out with the use of suitable tools, and then that edge will be cut out. So the surface that is cut is extremely clean, very sharp, extremely well defined. It's possible that the beam could be continuous and you could actually melt one surface and bring it next to the next second one and fuse the two of them together, result into welding. So welding, a very sharp welding of edges can be carried out. Automobile industries nowadays are all automated, robotically controlled, and there many a times these laser beams are used, cutting out sheets of metal for not only for automobiles but also for heavy industries, right up to shipbuilding. All these cutting processes can be carried out by using laser cutters. All engineering work of this sort, drilling holes not only in diamonds but in other hard materials also, can be carried out through steel, cutting holes through steel and so forth, puncturing things. All this can be done only because we now have laser beams that can produce that tremendous amount of energy and result into the cutting process. There is one more area where this is used. When I was talking of sound long back, I had mentioned that ultrasound can be used for surface cleaning. Nowadays, even soft type of lasers are used for surface cleaning. So, oils etc. can be cleaned, removal of rust, paint, etching them out, all that is possible. Also, after the product is ready, you have to engrave your company's logo and mark and other stuff, and normally that would take a long time. Now that it can be done on metal itself in the form of etching, so all that engraving can be done by using suitable lasers in the industry. Cutting, welding, drilling, for all this gas lasers are used. Typically CO2 lasers are the ones that are used. There is one more area where lasers are used in industry, and that is a very sophisticated area, which is making of integrated circuits. When I talked of electronics, remember I told you that there are ICs or integrated circuits that's a combination of not 1, 2, 3, 4, but right up to 1,000,000 or more transistors and capacitors and FETs and MOSFETs and other type of semiconducting devices that are put together on an extremely small, maybe a millimeter by millimeter or a couple of, at the most a centimeter by centimeter, on which you could have 1,000,000,000 diodes and semiconductors. How do you go and do that? So, what you do is actually make an extremely precise diagram first, because they are all circuits, and if you are going to use a person drawing with a ink pen is going to make a thick line and it might have edges, but then if you are using a laser beam, it can be so small, and then this can be focused, and this can be then further reduced and further reduced again, and in this manner all those circuit diagrams are reduced down. And all this area is typically referred to as microphotoLithography. Graphy is picture. In olden days, all printing used to be done by using stone blocks on which designs used to be carved, and then ink, and it used to go on. So, that is why it is lithography. That's why you must have heard of the word lithopress also. So, now of course, laser beams are used, and there is an added advantage. Since the intensity of light is extremely high, you can darken or change the nature of the material on which this beam falls, and so it is possible to etch parts or etch lines or deposit material or change the nature of the material and so forth using laser beams. So, the whole industrial setup has a number of points at which these laser beams are used to manufacture these integrated circuits, which will consist of not only conducting wires but of semiconductor devices also, that too at a very small size. Because of lasers, all this has been possible now, and all those big bulky things have reduced down to practically no size at all. But then information can be stored, and information has to be read again, and for that remember what I had talked of, CDs, computer disks, and ROM memories that have to be read. For that, the beam of light that is used is actually a very good quality semiconducting laser, and that is the beam that falls on the CD and reflects back, and this is the one that is used to detect the digital information that has been stored on the CD or the compact disc. Now, the amount of information becomes very small, very large, because the beam is very small. So, what you use is a lot of data stored, maybe a couple of hours to about 8 or 10 hours of music can be stored on just one CD in an MP3 format. But they realize that instead of using the normal light that is used, which is red, they changed it to using blue light, and the wavelength of blue light is much lower, around 4700 and something. So so it's about 60% less than the red light. So if the wavelength is smaller, it will be able to read and detect that much smaller things. So naturally the amount of information stored could become greater, and so now you have CD players that are known as Blu-ray players. Why? Because the laser beam inside is of blue color. So information storage and removal of this information, or getting this information back, is done by this particular method. There are many other areas in which communication is also carried out, and the reason this is done is because of the speed at which laser beams can work, the accuracy with which they work, and that is the crux. Also they can travel through vacuum, they are not affected by anything else because they are just electromagnetic radiation, and you can send them through optical fibers. But there are places where there are no optical fibers, so like space. So deep space communication is all carried out by nowadays by laser beams. Directed laser beams are used for communication. They act as high speed transmitters in digital form. They can also use analog form, it can be modified accordingly, and either you use fiber optics to pass on the information or communicate directly in the form of a laser beam. So you can send a beam to a satellite, but think what used to happen previously. A transmitted beam which is going to spread out, so the strength of the beam is going to become very weak. So naturally they designed those dish antennae etc., by which the beam gets focused. But even after getting focused, it again crosses over and then starts spreading again. But a laser beam is an extremely tight beam of information, and so the energy loss or the data loss or the strength weakening, all these problems don't take place when you are communicating with help of laser beams. So satellite to satellite communication or ground to satellite communication is more effective, and now in all advanced stages this is done by using lasers. There is one more word that you must have heard very often, and that is known as bandwidth. A band is a group of wavelengths through which information is going. And remember when we talked of radios and TVs, how information goes across. So it depends upon the amount of bandwidth that is available. But if you are using normal radio waves or microwaves or others, the waves themselves are pretty big. Once you start using lasers, you are in the visible range, and the waves themselves are extremely compacted. So in the same amount of bandwidth that is available, far more amount of data can be passed down in a very short amount of time, because the speed of course is 3 into 10 raised to 8 meters per second, that is the speed of light, that is 3 lakh kilometers per second. So the amount of information that is going to get across is going to be extremely large. So outer space communication is going to be using lasers. Think of objects that are going to go Chandrayaan and others. They are going to go so far away that sending a beam of information to them or receiving an information from them is going to get very difficult. Collimation, that is focusing, is going to be better if you are going to use lasers. So this is how it can be used, and also the information can be coupled to optical telescopes using a laser pointer. So using a laser pointer you should be able to track down where your satellite is and then go about by finding out or going through the communication process. In fact, how do you remember in school they told us how how distances are measured and so forth. So you send a signal and see how much time it takes for the sound to come back, and then you measure the difference and find out the distance. Then they started using light waves. But the trouble is, if I want to measure the distance of a moon, if I shine a torch at the moon, by the time the beam goes to the moon, it will be spread so much that hardly any light will get reflected and I won't be able to detect it. But if I send a laser beam, then it's going to remain a tight beam practically till it goes there, and then it is very likely that you would be able to detect that light that is coming back. That is exactly what is done. So precise measurements can be carried out if you are going to use laser beams, because then time differences etc. can be measured more precisely. So distances of various objects or moon and other stuff or satellites can be measured by using these techniques. Naturally, once these areas started off, people in the defense or military areas realized that all these lasers could be used for a lot of other techniques also, and so there are many laser applications that are used even for military purposes. The one that is talked least is shifting lasers from light to a much higher energy range, which is X-rays. So designing X-ray lasers could be the top next generation of weapons that could be talked of. As to whether they have come into practice or not is something that I need not mention or talk about, but that is where the future weapons would be. But then what about the weapons today? Realize that a beam of light cannot go too far and you cannot see the object that is illuminated. But a laser beam or a laser pointer that is used can send a spot that can fall on an object to a very large extent, which can be realized by people at night or even at daytime, even if the distance is very large. So nowadays all gun sights and rifle sights and others have a laser pointer attached to them. So the beam actually hits a spot telling you where it is likely that the bullet or the shell is going to go and hit. So this becomes a very important advantage as far as pointing guns or other devices is concerned. There is one more area, and that is known as homing devices. These are like homing pigeons who come back to their home. So what is done is, in such cases, realize the logic of what I am talking of. A bomb, a smart bomb or a missile has a method of detecting high intensity of light of a particular type that is fixed to it, and then using a set of gyroscopes it is possible to turn the missile so that it will be aligned along that particular direction. This is the first step. Now what do? Suppose a bunker or a site has to be bombed. So what you do is, you from a other distance you shine a beam of laser on that particular object. So it creates an extremely high intensity spot on the object of a particular wavelength, because that is the wavelength that is being used. Now your smart bomb or your device is going to detect that spot. The intensity is so bright that detecting it is not going to be very difficult, and then its homing mechanism takes over and redirects the object towards that spot. And so a homing device of this sort attached to a bomb will make it more precise on its results. So you would find that in military purposes there are many other areas also where Laser beams are used to find out distances, to track down information coming from objects and so forth. There is one more word that some of you all must have heard. It is known as LIDAR, light detection and ranging. Actually, it is just a sophisticated form of a radar, because radar uses radio waves. Instead of that, if you start using light waves, then the amount of information is going to be far more precise, and for that it is more sensible to use laser beams because they are going to be more effective. So all range finders, guiding systems, targeting systems are all controlled nowadays by using lasers. From 70s onwards, they started testing out a variety of other colors in laser beams, and so we have laser beams of a variety of colors, and they are all used nowadays in entertainment, in light shows, in planetoria, that is where in a planetarium where different constellations and others are shown. So pointing them out becomes very easy. In concerts, in hall ceilings, outdoor areas, all these laser shows are nowadays conducted. A light beam can't be seen, but if there is a particle in its path, the particle gets illuminated and the path of beam can be seen. So what you do is you provide these particles to get illuminated. So either you create smoke or you produce water droplets, and these get illuminated by the laser beams, and then you can actually see the beam as it travels or moves around. Not only that, there is another aspect associated nowadays which is known as holograms, which results into projection of 3D pictures. How does it go about? This photograph behind, for example, is a photograph that has been printed, but this is the original statue. This is 3 dimension, that is in 2 dimensions. So I can bend around here and look at the area behind or from the side, but I can't do that there because it's 2 dimensional. So how do you create 3D images? And or stereoscopic vision, as we typically refer to, what do you do? So a new technique of light was used. It uses a principle which is typically referred to as, I talked of this when we talked of the basics of light. It is known as principle of superposition. It results into 2 phenomena. One is known as diffraction, and the second one is known as interference. It's common sense. There are 2 waves. If they reach the common point at the same time, both of them going up, that's what, for example, if there is a boat in a river, and there are 2 waves that reach the boat. If the both waves reach with their crests, the boat will be shifted up double the height because 2 of them are there. If there a trough is reached, it will go sink downwards, and if a crest and a trough reach, they will cancel out each other and the boat will hardly move. So the effect seen at a particular point depends upon how the waves meet at a particular point. This is the first step. So what do? Rather than taking a normal photograph, you use a laser beam and split it into 2 parts. One part falls on the object itself, and the second part falls on the photographic plate or on a recording surface. And the first beam hits the object, turns around and falls on the same plate once more. So you have light coming from 2 directions, one a direct beam and one a reflected beam. Naturally, there is going to be a difference depending upon what is the shape here. So naturally the waves are not going to match, and they are going to result into a pattern, interference pattern, because of the superposition of the 2 waves. It won't create a photograph, but it will create a completely different pattern that is there on it, and this is recorded on that particular sheet. Now you use the original beam once more and illuminate that sheet, and what happens is the same projected original image now appears in front of you in 3 dimensions. And this is how holograms and holographic projections are produced. So then you can bend around and look around and see the object. This is one more very big advantage. Suppose I take a photograph of an object and cut it out in a small piece. The photograph, if I have a small piece, it is that only that part that I will be able to see. But in a hologram, all the information is stored at all the points everywhere. So if I take a small, if I have the whole hologram and I take a small part of it and illuminate it by the suitable wavelength, the complete image will be seen there. I might have to tilt and bend and look around, but I will be able to see all the image there. So this is how a hologram is different from normal photography. It started off by using lasers, but as time passed, things improved, and nowadays we have holograms that are sensitive to even visible light, and the result is all these holographic decals that are used to identify your own company product, because making a hologram is not really very simple. And so you buy a sophisticated company's material, a camera or a calculator or something of this sort, or a laptop. They have their own hologram that is stuck on top. It's not something that a spurious person can just make offhand and make a duplicate copy and put it there. It's pretty difficult and complicated. So but when you make it in bulk, in millions, then it's going to work out to be much cheaper. So these products will now be identified by using these holograms. So that's an area that is talked of. But what about other day-to-day areas where we look around? The most common one is, of course, laser pointers. So rather than use a rod and point out at things, use a laser beam that can be used to point out things. It's dangerous. I have already told you that. I could have shown you the laser pointer that I have, but it's not fair. If I point it this side, it's not going to really, it's not a good thing to point it at somebody. The other area that is talked of nowadays is laser printers. Printing previously used to be done by ink. Rather than printing by ink, you have a laser beam which is very sharp, very precise, and very small in size also. But the intensity of the light used can be used to darken certain chemicals. So you use a beam of laser to make the necessary writing marks, and so you have what is known as a laser printer. You have CD readers, you have projectors that are made out of lasers, laser pointers, and nowadays one more major area that we know all know of is when you walk into a shop and buy something, he uses a scanner, barcode scanner, and scans the information, and then it is recorded as to this particular object is being sold out, and it has to be removed from the inventory, and the amount has to be added to the amount that has been taken in, and this is the amount that is taken in, and then it can be added on, so forth. Inside, what is there is a small laser that sends out a beam that is used to reach these barcodes. So barcode reading is done by this particular method. So you would find that there are so many applications that we have. It really depends upon the ability of an individual to decide on how lasers can be used. Lasers can provide so much. I have just listed out some common ones, some common applications that we know of. If you have liked whatever I have said, please like and subscribe to this channel. Tell your friends about it. If you read about all this information sometime, all what I have said should make it more easy for you to understand these topics more conveniently. Is that all for lasers? Not really. There is one more topic in lasers that we must talk of. But for that, we will have to meet next time. Till then, Namaskar.